Welcome to MRU E-Learning, powered by Ballareddy University. Myself, MV Padindra. I'm working as Assistant Professor in Department of Data Science, Ballareddy University, Hyderabad. So today, my topic is Joins in Structured Query Language, SQL. So, what is SQL? SQL is a non-procedural language. Basically, non-procedural language describes the desired result. Like SQL, we have many other non-procedural languages like Prolog, LISP, Query by Example, and HTML. And of course, we have few other non-procedural languages also. And coming to this procedural language, we have regular C, C++, Java programming languages. Of course, it is purely based on step-by-step instructions. And here one important point to be considered is SQL implements RDBMS concepts. What is RDBMS? Relational Database Management System. So now what is RDBMS? RDBMS is the capability, it is the ability to store data in the database, modify data in the database, and retrieve data from the database. And we have so many RDBMS softwares like Oracle, MySQL, SQL Server, PostgreSQL, and all these are RDBMS softwares. And the common entity among all these RDBMS softwares is SQL, Structured Query Language. Only simply to say what is SQL means, SQL is the only tool which maintains communication with the database in simple terms. And moving to the actual topic. So now we are done with SQL. So my topic is, today topic is joins in structured query language. So I have given some basic introduction on SQL. Now moving ahead, now I'm just into SQL joins. So what are SQL joins? So SQL joins are used to retrieve data from two or more tables that have an logical relationship between them. So basically joins, in the English term joins. Joins purpose is to retrieve data from two or more tables. One single point to be understood is what is table. So table is the place where data is stored. Table is the place where data is stored. So here you are having two or more tables. From these two or more tables, there is a logical relationship between them. So that is being retrieved by means of this joins. Then moving ahead. So in this SQL, you should be aware of some, so prerequisite knowledge to this SQL joins is, you should be aware of some basic SQL queries and keys. So the first terminology is all about connecting two or more tables having logical relationship, which is nothing but joins. And the second point here, we have keys concept. This keys concept, we have two terminologies. One is primary key, another one is foreign key. So basically, this primary key and foreign key are used to connect table 1 to table 2. So it establishes relation between any two tables. So understanding of this keys also is very much important for this SQL joins. And then moving ahead, so here it is very important to understand that when we combine data logically so how we are combining data logically? We are combining it from two or more tables. So whatever data that we are combining, that is specific to only query execution only. So when you are merging tables, there is no permanent saving of data. So that is only temporary up to for query execution. So then moving ahead, so I'm just into various types of joins. So here we have various types of joins. One is inner join, second one left outer join, third right outer join, fourth full outer join, fifth cross join, sixth self join, and seventh one natural join. So then I'm going to explain each and every join separately with syntax and examples. In SQL, writing syntax matters a lot. Based on syntax itself, we'll be writing queries. In the terminology SQL, we have queries, so we'll be working purely on queries. As it describes the first one, inner join. So inner join. So before moving into this joins concept, I just want to tell you something about set theory. Set theory is a mathematical way of representing sets. And coming to database point of view, we will consider it as tables. So here, in this particular inner join, we have A and B. So as per set theory, nothing but mathematical equations, A and B are nothing but set A and set B. At the database point of view, so those two are considered as table A and table B in table where we are storing data. So here, to be specific, rows that have matching values in both the tables, I mean table A and table B, wherever you are having matching values, those values are going to be displayed by means of this inner join. So then moving to syntax. So in the syntax, you can see, so I told you SQL queries basic prerequisite knowledge is required for this. So here you can see, so select table 1, column 1, table 1, column 2, table 2, column 1. So here you can see, so as per this syntax, you can find select column list, means set of columns of a table from table 1, inner join, table 2 on table 1 dot matching column is equal to table 2 dot matching column. So I'll just summarize this syntax. Here in this, you are selecting list of columns from the two tables. So you can say table 1 dot column 1, table 2 dot column 1, table 1 dot column 1, table 2 dot column 1 means from two tables you are capturing two columns. So you can gather any number of columns. Okay. So select the column list from table 1. So table 1 is getting inner join with table 2 on the condition basis of condition is very much important in joins. Table 1 dot matching column is equal to table 2 dot matching column. So what is this matching column? So it is mandatory in joins to have one common column in two tables with same values. Okay. So even here, I have a note here in every join. We can also write join instead of inner join. Join is same as inner join. Okay. Next. So this is the example of inner join. So I just told you table A and table B, right? So in the same way, I have here two tables. One is student table, another is student course table. So here in the student table, you have roll number, name, address, phone, age. And here in student course table, course ID and roll number. So I told you that as per syntax, you should have matching column. Without matching column, without any condition specification, there is no combination of these two tables. So here, what is the common column in these two tables, student table and student course table? Roll number. Roll number. So roll number is the matching column in these two tables. And within that, matching values also should be considered. Values matters a lot. Having column name is not important. Having common values is very important. So what are the column values we are having? 1, 2, 3. 1, 2, 3. So these three are the matching values from table 1 and table 2 with column name as roll number. So this query will show the name and age of students enrolled in different courses. So here you can see the query. Student select student course dot course ID. Student course is nothing but second table. Course student course dot course ID. Have chosen course ID from student course. Student dot name. From this table, student, I have chosen name. And for the student course, I have chosen course ID. Comma, student dot age. Have chosen student dot age from student table. So totally I have chosen 3 columns. Okay. From 2 tables, that is student and student course. From student, inner join, student course. So what we are doing now? Inner join. We are working on inner join, student, inner join, student course. And what is the matching column you are having? Matching column is roll number. Roll number in these 2 tables. So as per inner join, student course on student dot roll number is equal to student course dot roll number. So here student is table 1, student course is table 2. So what is the matching column? Roll number. So as per inner join, again I repeat, so you'll be retrieving only common values. So whatever common values are there, those will be displayed here in the output. So here, what are the matching columns in these 2 columns, roll number and roll number of 2 tables? 1, 2, 3. So which I have specified earlier. And the relevant values also you can see. Harsh, Pratik, Priyanka. Harsh, Pratik, Priyanka from student table. 18, 19, 20 age. Okay. 18, 19, 20 age from student. And course ID, so course ID, you have 1, 2, 3. 1, 2, 3. So inner join, you are getting only common values. Okay. Now, we'll move to the next one, that is left outer join. So in the beginning, I told you inner join, left outer join, right outer join, full, cross, self, nasal. So we are into the second one, left outer join. So left outer join. So here you need to concentrate more on this red mark that I have given. So here left table complete plus matching rows plus null for unmatched right table rows means. So here complete set of rows from the left table, that is A, will be displayed. Matching rows of A and B will be displayed. And whatever rows that are left from table B, that will be shown as null. And of course, this syntax is similar to that of inner join. So here you can see, select table 1 dot column 1, table 1 dot column 2, table 2 dot column 1. So we are checking list of columns from this select query from table 1. And see here, it is an left join. So table 1, left join, table 2, on table 1 dot match column is equal to table 2 dot matching column. So this is same as previous syntax, but only the thing is, we just replaced inner join with left join. And in left join matters a lot. So here in this left join, again I repeat, left join has complete set of rows, matching rows of left table and right table, and only nulls are going to be saved from right because it is not matching. Left is purely, as our topic is left outer join. So the same example you have student table, student course table. So here using this left join, I'm going to retrieve all rows from the student table and the matching rows from the student course and student table, which is based on roll number column. Roll number is nothing but matching column. And see here we have left join. So select student.temp, student course.course ID, student is table 1, student course is table 2. So 2 columns have chosen from student. Left join, student course on student course.roll number is equal to student.roll number. So these two are matching columns for left join. And here you can see the output. So within this output, what we are trying to display only name and course ID. You can see course ID. So what is the matching column? Roll number. Okay. So I have chosen course ID from student course. So what are the rows displayed? 1, 2, 3. 1, 2, 3. Okay. And adjacent to this name is from student table. So from this student table, what did you get? Hers, Pratik, Riyank. So name is from left table. So this Deep and Anita, these two are belongs to left table. And when we are combining with this right table course ID, these two are non-matching. Okay. So again, you can see here, left table complete, matching rows, plus null for unmatched right table rows. So null matching, these two are unmatching null rows of right table. And this is complete left table. And these are Harsh, Pratik, Riyank, 1, 2, 3 are matching rows. So again, so then the second one is left outer join and the third one is right outer join. So almost this is similar to the previous one. And here small adjustment. So here right table complete set of right table rows will be displayed, matching rows of left table and right table, and whichever it is not matching in the left table, that will be shown as nulls. And need to concentrate this syntax with right join, and obviously matching column is itself comparing those two tables. So here the same example, student table, student course table. And here right table is student course, left table is student. And here as per this query, student.name, student course dot, student course ID, right join, and matching columns are roll number. And here you can see, first let us check as per this right table complete. So right table complete means what you have chosen? You have chosen course ID. Course ID You have got 1, 2, 3, 6. So it's fine. And matching rows. So what are the matching rows in these two tables of name from student, course ID from student course, Harsh 1, Pratik 2, Riyanka 3. So these three are matching. And it's an complete right table. Harsh, Pratik, Riyank 1, 2, 3 are matching columns. And left table, it is shown as null because it is a non-matching record when it is combined with 6. Fine. So again I will move to the beginning. So far we discussed about inner join, left outer join, right outer join. So now we are into the fourth scenario of full outer join. So what is full outer join? So full outer join means a simple thing. When we are combining left outer join and right outer join, so its representation is full outer join, mean complete rows we are trying to show. Okay, but there is some difference between left table and right table when compared with full outer join. So obviously here you are representing full outer join by means of this keyword full join, and the matching column itself, it is combining two tables. And see here the same example, student table, student course sub. And see this red mark area, this is very important. Full join, which combines the results of both left join and right join, the query retrieves all rows from the student and student course sub. If a record in one table does not have a matching record in another table, if a record in one table does not match record in other table, the result set will include that record with null values. This null values is important. If any such non-matching records are there between two tables, it will be displayed as nulls. And see here, as per this query, student.name from left table, student course dot course ID from right table. So from course ID, full join, stored student course, and matching column is roll number. So here name is from left table, course ID is from right table. And you can see left table Harsh, Pratik, Riyanka, Deep, Anita, and you can see null at the end. And here right table course ID 1, 2, 3, null adjacent to Deep, Anita adjacent to Anita, it is null, and 6 is displayed here. And here what is happening here? So if a record in one table does not have a matching record in other table, so whatever matching records are there, those are displayed. So course ID matching records are displayed here. Course ID matching records are displayed. Name matching records are displayed here. Course ID matching records are displayed here. Whichever it is non-matching, it is represented as nulls. So this is about full outer join. Then moving ahead, we are moving into the concept of cross join. So what is cross join? So here almost the same image we have seen just before. That is, see here, full outer join image and cross join image seems to be same. But there is a difference. See, cross join means it simply returns Cartesian product of two tables. Cartesian product is nothing but one of the terminology in set theory. Cartesian product means simply multiplication of any two tables. So here remember one thing, in this cross join, we are not using any conditions. And in full outer join, left outer join, right outer join, we are applying some conditions in matching records. We are applying conditions using matching records. And here, in this cross join, you don't have any matching record. There is no condition. So here you have table 1 and table 2. For example, if you are having 2 rows in table 1, 2 rows in table 2. So total, as per Cartesian product, nothing but cross join, it will be displayed as 2 into 2, 4. So here you have one example also. There are 2 rows in customers, 2 rows in customers, 2 rows in orders. So here it will be displayed as 2 into 2, 4 rows. So complete list will be displayed. So in case, in table 1 you are having 5 rows and in table 2 you are having 6 rows. 5 into 6, 30. 30 rows will be displayed. Simply Cartesian product is simply multiplying table 1 with table 2 without any condition. So there is no logical connectivity between two tables. Simply it is displaying all set of rows. So there is logical connectivity is nothing but establishing and having a condition between two tables, having matching columns. So which is there for inner join, left outer join, right outer join, full outer join. Okay. So the next one is self join. So this is very, very important topic in joins. That is self join. So far, what did we discuss in our previous joins? So we discussed about more than one table, table 1 and table 2 combination. It doesn't mean that you have to limit yourself to only 2 tables. It can be any number of tables, 3 tables, 4 tables, 5 tables. But establishing logical connectivity among multiple number of tables matters a lot in joins. So now the concept is on self join. So what is self join? So simple terminology, self joining means joining a table to itself. Joining a table to itself is known as self join. So here you are going to work out with only single table. Here you can see syntax, select columns from table as alias 1, table as alias 2. So here table. So both are same tables. So you are choosing only same tables, but you are giving different names to that by means of alias names. Alias names are nothing but simply giving, it is like nicknames given to any person. So the same table you are giving 2 different nicknames. And there is a logical connection within a single table itself by means of writing alias 1 dot column 1 is equal to alias 2 dot column related column. Okay. So of course, this is something which you'll understand very well with the support of example. Okay. So here only the thing is same table we are giving 2 different names, alias names. Okay. So see this example. So in this example, so the actual table name is GFG employees. And here in this table you have 3 columns. What is here? Employee ID, employee name, manager ID. So you should be concentrating much on these values. Employee ID, employee name, manager ID. So here I have given 3 columns. So what is this self join? Self joining means you are working only on single table. So see the syntax. See the example here. Already we have seen syntax. Select E dot employee name. Select E dot employee name. Select E dot employee name as employee. See here. Here, as per the syntax, alias names are there for tables, and even for columns also you can do alias names. E dot employee name as employee. See here, alias name is displayed here. M dot employee name for this column. So employee name. So you have only one single column, that is employee name. So you have given 2 alias names. E dot employee name as employee. M dot employee name as manager. So E dot employee name as employee. M dot employee name as manager. So I have given alias names for the same column employee name. From GFG employees. So GFG employees, to this table name I have given 2 other alias names, E and M. From GFG employees as E, join. GFG employees as M. GFG employees as M. M on E dot manager ID is equal to M dot manager ID. So here E dot manager ID is equal to M dot employee ID. See in the beginning itself I told you having same column names is not important. Having same values within those columns is very, very important for this joins. Okay. So do you have 3 and 4 here? Yes. This 3 and 4 here? Yes. So that becomes the basic logic for connecting this manager ID and employee. So I'll just I will repeat this example once again. Select E dot employee name as employee, M dot employee name as manager. So employee name as column names have given alias names as employee and manager. From GFG employees as E, GFG employees as M in between join. So GFG employees table name have given E and M as alias names. Employee and manager for column names. From column name, employee name. Okay. So and here I have specified the condition E dot manager ID is equal to M dot manager ID. So employee E dot manager ID is equal to M dot employee ID. So here we can see matching values are there in these 2 tables, 2 columns. So that is why you are able to write this condition. Okay. So of course this is fine, but to understanding this output also matters. So here left side within this employee you can see Oliver, Sophia, Daniel, Emil. And in this right side manager you can see Daniel, Michael. It seems to be a little bit confusing, but you need to have proper understanding on these values. As per this example, you can see adjacent to this Michael manager ID, it is showing empty, which means, say, try to understand those column names like in English, employee ID, employee name, manager ID. So adjacent to this Michael, it is showing purely empty, which means Michael does not have any manager. and his employee ID is 4. So his employee ID is 4. So within this manager ID, where do we have 4? Here and here. So which means Michael does not have any manager, right? So in the same way, so 4 and 4 is available adjacent to Daniel and Emily. Daniel and Emily, which means Michael is the manager of Daniel and Emily. See here, Daniel, Michael is the manager and his subordinates are Daniel and Emily. So Michael is the manager, Daniel and Emily is the subordinates to him. So Michael does not have any manager. And moving ahead, and here you can say Daniel. So Daniel, left side to this Daniel employee ID is 3. So here top two rows you can see Oliver Sophia's manager ID is 3. So obviously Daniel is the manager of Oliver and Sophia. So simply using this self join, we are trying to combine a table to itself, but only the basic criteria to be understood is 2 columns should have matching values. So the next one is natural join. So natural join. So here, even this natural join set theory, way of representation seems to be seen somewhere else, right? So in the beginning itself, we have inner join. So inner join and the natural join representation is same. So what is it? In inner join, what did I explain? So inner join, rows that have matching rows in both tables. And remember one thing, rows that have matching values in both tables. And here in this inner join, what did we use? In inner join, we used this combination. That is, we applied one condition over here. So based on that condition, matching rows are displayed. And coming to this natural join, see here, you're not specifying any condition. You are not specifying any condition here. A natural join is a type of join that automatically matches columns with the same name and compatible data types in both tables. So here you need to concentrate more on the terminology automatically. So here, so in inner join and natural join, only the point to be differentiated is in inner join, you are using condition. In natural join, you are not using any condition. 2 tables will be combined based on the matching column automatically. So here you can see student ID, name, age, student name from students table. Student ID, subject, marks from marks table. So here the common column in both tables is student ID. So what are the column common we are having? 1, 2, 1, 2. And here select the start from students, natural join, marks. So here I did not apply any condition, simply I have used natural join. So what it is trying to display? So just need to concentrate on this 1, 2. So 1, 2 of this students tables you can see 1, 2, Ravi Priya 2021. From this left table students. And the right table you can see 1, 2 is the matching, right? So subject maths science 98. So here only the thing is natural join and inner join difference we should understand. In inner join you are applying some condition, and for this natural join it is automatically combined. But you will be having some thought in your mind. So which one is best? So obviously inner join is correct approach to work with it. In complex scenarios, this natural join won't work. Thank you.